Hi, this is Jeff from the Ozark Mountains in Missouri, USA. Well, this video is about all of this stuff, and well, what is all of this stuff? You can see on the small box it says it's got some parts in it. This medium-sized box actually has some case parts for a TRS-80 Model 100 and a couple spare LCDs. In this huge box, which is right at 23 pounds, is a 6-pack of TRS-80 Model 100s. How about that packaging job? That is awesome. The fellow that sent these to me needed some help to get them fixed for a variety of reasons, and he was also downsizing, so we did some horse trading. I want to fix these up for him. He's provided most of the parts here, so we'll get them fixed up. We'll test them with the test harness and then get them shipped back to him. And the three on this side I think are the ones he sent to me to keep. They're a little more beat up, a little more yellow. They're kind of more, parts-ish, rougher machines. So in another video, we might see what we can do with those, maybe retrobriding the yellow cases, that type of thing. So let's get started. Thanks to PCBWay for sponsoring this video. They not only do PCBs and flex PCBs, they also have 3D printing service, injection molding service. They do CNC machining, sheet metal fabrication. They also have a thriving maker community where you can share projects and check out what other people are doing. For your next project, head on over to PCBWay. I turn that big box upside down and let these slide out. And on these three, the more yellower ones, he did leave a note that said yours. And these are the nicer ones, which I'm going to send back to him. So I'll get the camera up overhead and we'll pick out one and we'll test it out initially, and then we'll get to recapping and testing it out. Here is candidate number one. As we can see here on the top, it's in pretty good shape. A little dirty from use, but not too bad. The LCD is a little scratched up. Maybe we can polish that out. This side's good. On the back, he had mentioned he had trouble getting this board off. This is an interface for a Chipmunk drive, I think it's called. I think this was a PG Designs product. It can be a little tricky to get popped out of there though. Which we kind of need to do to take the case apart. Battery compartments. Yeah, there's some signs of some corroded batteries in there. It's pretty rusty. That's going to be a problem. We have to replace some of those springs, and we're going to have to get this guy popped off of here somehow. I wonder if we try to pop the case off, if we can walk that board out. Oh gosh, the screws are in there tight. I forgot to show you, this does turn on. Apply some power through the external jack. You can see without all the glare from my overhead lights, it does fire up just fine. The date comes up and it displays a serial number here, which I think is from that drive adapter board. So let's take the rest of the screws out of here. Gosh, those are really tight. Open that up like a book, and this does have the Y2K compatible ROM in it. I think there's some other circuit boards for those in the box of parts. It's got the original memory battery, which we need to change. It's got the original caps, which we need to change. And there's a little corrosion, but it's not too bad. Okay. So let's unplug the keyboard. And the LCD. Corroded batteries didn't do too much here. Quick quick look at the circuit board here with my old man glasses. There's someone else said in a video comment, they're not old man glasses, they're the glasses of experience. Don't really see any signs that the corrosion from the batteries has gotten on either the keyboard or the LCD, which is a good sign. And what we'll try to do now is take this board out and try to work that extra board loose. There we go. Huh. I just pushed on the option ROM socket and it popped this little guy loose. And all the pins are still intact. Okay, I did a video on these sorts of add-on boards and how to find those little pins when they get broken off. This says Holmes, component side. Sometimes these battery contacts are a little tough to get loosened out of the slots they go into. There we go. Most of the little rubber donuts have gone missing out of here. Oh, no, they're under it. Just managed to dump them out of there really good. Okay. Bottom cover, and we're down to the board. So, looking at this, as far as corrosion, there is a little visible there, around all these smaller caps is generally where it's worse, but it's some here, some there, not too bad. Looking at the back of the board, we have, of course, the nasty flux, which is always a pain to get off, but when it's this thick, I always like taking it off. This bodge wire is from the factory, as is this. This has had a bit of flux get to the top. I think the first thing we'll do on this is remove the old caps in the battery, and then we'll give this board a good wash, see what damage there is from the leaking caps, etc. Okie doke. I'm going to remove all the electrolytic caps in one shot. I've got my capacitor map here, link to that in the description. It's color coded, it tells you which side is negative, etc. I find on these boards it is easier to tip the capacitors out because there are some thick power planes on the front side of the board and it's hard to get everything heated up. So this is fairly easy. You heat up one pin, pull the cap out as much as you can, heat up the other pin, do the same, and you just walk it out like that. That's all there is to it. Now let's see. This one is a leaky one, it always is. The Model 100 is one of the few machines I always recap because all of them leak. And by the time they got around to making the Model 102, they had figured out the capacitor technology and never seen one of those leak. Doesn't mean they can't, but I don't bother replacing those because they're not leaking, they're still working fine. And every component you remove is a chance for damaging the board. Yeah, there is some corrosion right in here. Let me zoom in on that so you can see it. zoom out. So right in here, that's pretty normal stuff. Okay, oh, wrong way. We'll zoom out again, and I'm going to get the rest of these caps out of here, and then we'll clean the board. I got the electrolytics removed, and I had to remove a few other capacitors that were kind of hanging out in the area where some corrosion was. That's not unusual. You've got to get stuff out of the way to get all the corrosion out of there. Now I'm going to go back over and put some fresh solder where these capacitors were. And what we'll see is, like on this cap, the pads it goes into, the traces it goes into are on the top side of the board. And we might have problems desoldering those from the bottom of the board, depending on how thick the traces are. This is a good example here, if you can just see that. This top one has the trace on the top of the board. This one here is on the bottom of the board, so we can probably get this bottom one. That one came clean. Now we'll try to get the top one. Oh, my rosin fell down. Actually, we got all of that one. That's good news. I'm giving this about 5 seconds to warm up. Oh, we're getting lucky on this. There are half a dozen joints here that have thick traces on the top side of the board, and they're very difficult to desolder from the bottom. So if we look at this guy right here, you can see this area is corroded. So I'm going to gently scrape that with a small flat blade screwdriver. You want to make sure you use a screwdriver that's not real jagged on the bottom. We're not trying to put gouges in the copper. We're just trying to get the corrosion and the silk screen off of there. Take your fiberglass pencil or pin, buff that area off like that, and we can see the problem here is this hole is coming up right into a power plane. There's no thermal relief there. So in order to desolder that, got to apply some solder, some flux, I'm just going to go ahead and coat as much of this bare copper as I can with some solder. This also kind of preheats the copper. Okay. Let that heat up with the desoldering tool. And we've got our hole clear. And we've tinned our blank pad up there. And you notice we've got the same thing here and over here. So I'm going to go ahead and clean those up. Get all our holes clear. Scrape down the crusty parts. Tin it. And then we'll worry about washing the board. Okay, I've spent about an hour removing the electrolytic capacitors, the battery, clearing out all the holes, fixing all of this corrosion, tinning those areas. We've got here, here, here. Those are all common. Here, also a common spot. And in this area, also a very common spot. And this one's not too bad. A little less corrosion than average, I would say. But altogether, this board cleaned up nicely. What the solder sucker doesn't get off the pads when you tin them, you can use some braid and get most of the excess solder off of there. I did pull the inside leads off these two resistors and this diode, pull them up, clean those pads. There was a little corrosion on there, which I think was from the batteries. The battery terminals here are physically okay. There's a little rusty from corrosion, but you can take your fiberglass brush, get the loose stuff off there, then we'll put a few drips of citric acid on there and clean it up. These are unusual contacts, so it's good that those are okay. The other ones, it's in the battery box. We can swap those out. So now that this is done, we need to clean all of the flux off the board. It's very difficult to see in the video, but you see how shiny this is? That is a really thick rosin-based flux they put on the board. And after all these years, it can start to conduct. It's nasty stuff, so I like to clean it off all the machines. I've seen it cause phantom key presses. I've seen it cause the power supply not want to start up. Seen it cause the reset circuitry to act wonky. And I had one RAM module that got so much flux on it after all these years, it started malfunctioning. Desoldered it, soaked it in alcohol for a couple hours, and it was fine. That was an oddball one. So now let's clean this board up. All right, now we need to clean this nasty flux off the board. Gonna rotate this guy around like this. Prop up one end of the board, kind of like so. Got some denatured alcohol in this cup. I've got an old toothbrush. And a bunch of elbow grease. That's all there is to it. Now I've tried adding a thickening agent to the alcohol to let it soak on there. I'm not sure that actually does much. It seems like some good old elbow grease. You see how yellow that is coming off of there? Elbow grease, want a little time, take care of it. And, you know, we'll need to clean the back of this board like this 3 or 4 times. To get it clean, we'll need to do some cleaning on the front. You can see how much nasty stuff is coming off there. So we'll just keep cleaning this like this. Let it dry. It'll start to turn white. Clean it again, and then we'll give it one last hose down with some electronic cleaner, which I'll show next. You can see how much stuff we've gotten off the bottom of the board already. And if I tip it up at an angle, you can see how this whole bottom side has turned white, and the first time you do this, you'll think, oh my gosh, what did I just do? This is just the residue of the flux, and we need to use a different method for trying to get more of that off there. So again, we'll just wet it with alcohol, scrub it with a toothbrush. This time I've tried to keep the board flat. Clean rag. I learned this from YouTube, from Noel's Retro Lab. Put your clean rag on there like that. Go over it with your toothbrush. That'll push it down into the board. And you'll pick up the stuff on your rag. So that'll get a lot of it off there, and I'll do the thing where I rinse it down at an angle and scrub it with the toothbrush again. Cover it with a rag again. Let it dry. See how many more times I need to do that. We want to get all this off of there that we can. And doing this, you're going to get some alcohol leaking through to the front. And so we're going to need to do the front as well. This has a lot of flux on this side anyhow. So after I get most of what's the big stuff on the back, then we'll come to the front and clean it up. Here is the back after round number 2. This one's cleaning up pretty good. Some of them were a lot worse. You might be able to see around the switch we've got some white. There's some white up here. The sockets are always hard to clean. I did one round on the front and it's pretty good. It'll need another round. It's still like really sticky on this edge, things like that. But you can see how much has come off on the rag. So when we just have areas of white left like that, I'll go over those with a Q-tip. Try to get that off there like that. You'll see it over on the connector. Just be careful in this option ROM socket that you don't snag the contacts with your Q-tip. It'll get on the sides of the socket. Try to get all that off there that you can. Okay, we'll start round 3. I'm going to do it flat again, pick up what I can with a second clean rag. Got our second rag, and just like we did before, I'll go over the front side. That's a little harder to scrub with the toothbrush. Do as good as you can, and then we'll get it with the CRC electronic cleaner. Alrighty, I'm out in the garage now. You can probably hear it thundering and lightning outside. I've got some CRC electronic cleaner, not the CRC electric cleaner. You want the electronic cleaner. Got the board. You might just be able to see it's got some white down on this end on the top. The bottom's looking pretty good. I'm going to give this a hose down. Notice I'm doing the Michael Jackson here with the one glove on. It's really hard getting these sockets clean, getting all the stuff out from under them, so I like sticking the nozzle through the holes there. Just let all that stuff run off the board. And it's really hard telling how good a job you did until it dries, and if there's more stuff left on there, you'll see that white residue. So this is about all there is to it. With all the boards, or all the M100 boards I have to do, I'm going to have to order some more of this stuff. And I'll keep going at this, and we'll let it dry for a few hours, and we'll seal up where we've got our tinning done on the board. Our board's looking pretty good. I did have to spot clean some areas, especially on the front of the board, with a Q-tip and alcohol. I've got my Circuit Works overcoat pin. Touch up the silk screen. Just kind of seal things up. So this makes the board look better, helps protect it. This isn't the UV curing type. So just going to do this everywhere I had to scrape the solder mask off, and then we'll let it dry overnight. I pulled the battery contacts out of the battery box here, I'll pop some pictures up. They were quite stuck in there with the battery corrosion. Distorted a lot removing them, so I've got some new contacts here which I'll put in. I bought a big box of those years ago from AliExpress. It's nice that you can just replace contacts rather than try to reuse super corroded ones. These aren't too bad. They didn't get distorted. They're not too corroded. You saw I already scraped on those with the fiberglass brush. And in this container, I've got some citric acid. It's about 20%. And I'm just going to apply some of that to these contacts. Let it set for a bit and go over it again with the fiberglass brush. Get rid of any of the last corrosion on there. If the original contacts hadn't deteriorated so badly, I would have just dunked those in the citric acid for a few minutes and that would have been fine. I'll keep applying this because it runs off pretty easy. And I'll go into the bathroom and I'll add some to the crevices of the bottom cover. Let it set for a few minutes, flush it out with water, let it dry overnight before installing the new contacts. And I'll need to flush those with a little bit of water, not getting the water on the board, and then do that cover. And then I guess we can go ahead and put in the new caps. I opened up the capacitor kit that this fella got. There's several places you can buy these online. I don't like them. I prefer ordering my own. That way I know what I get. Because this type of thing bothers me. This is the size of the capacitor that was in the machine originally for these little 10 microfarads. It is a 10 microfarad 16 volt. It's on a 5 volt rail. Generally the capacitors will be rated about twice the voltage that they're going to see on the board to allow for any spikes or anything. What come in this kit was 10 microfarad 50 volt. Now, generally, if you're doing a capacitor replacement, you can safely go to the next voltage range cap if that's what you have in stock. If the board's designed properly, you're really not buying anything there. The problem is going from a 16 volt cap to a 50 volt cap, the ESR is higher. And in some cases, that'll bite you in the butt. So here is more of the original specification of cap. And hopefully you can read that on the video. Let me zoom in here. So 2.4 ohms. Here's one of the ones from this kit. 3.6 ohms. So we've got about 50% higher ESR. For this particular power supply circuit, which is what these are in, it's a switching type power supply. But it was designed for the capacitors available in the early 1980s, so this will probably still be fine. The larger size can bite you in the butt sometimes. We've got a few locations where we've got capacitors that are close together, and if you don't use the same can diameter and height, you can run into a problem. So we'll go ahead and fit these. I think they'll work fine, but it's one of the things I don't like about buying kits that are online. You don't know what brand you get or if they're going to fit. And these look decent. Some of them are Nichicon. That's a good brand. I don't know what the NNR brand is. That one's a Nichicon. So Rubicon. So some good brands and some unknown brands to me, but we'll pop these in and see how it works. All right, I went ahead and fitted these capacitors that are closest to each other to make sure they're going to fit, and they do. I think some of these are a little taller than the original. Hopefully it'll fit without a problem into the case. I've seen some pictures of people that recap and they buy these huge capacitors and push them over, and it just makes for a really crappy job. So we have C82, which is a 4.7 microfarad 25 volt. This one is 4.750. And as I showed, the negative side of the cap is shown on the capacitor map. I'll put a link to that in the description below. This is the one for up here, which sets sideways. Its negative is on the bottom, which is kind of hard to see here. What you got to do is bend the leads right at the body of the thing. Okay, that fits. This is a much smaller cap originally. Sometimes you got to do that because that's what you can get now, but it can bite you in the butt. So I always try to get ones that are electrically and physically as close to the original as possible. Okay, so now I poke the capacitors through here and I spread the legs apart to hold them in place. And I'll solder one leg on each. Just tacking it in there. Okay. Then I'm going to push up on the cap. To make sure it's in the proper position. And I'm letting the iron stay on the cap for 3 to 5 seconds. You need to get the whole joint hot enough. It's not going to show in the video, but the holes are bubbling a little bit. That's just from the process of washing it. Maybe some small bits of stuff still left in the hole. Just let the flux from the solder work that out. There we go. Now we'll just get the other legs. Okay. I'm just going to clip these leads one at a time while holding them. That way they don't fly up my nose or on the floor so I step on them later, that type of thing. And that's all there is to recapping. It's not really exciting, but it is necessary on some boards. One other thing I want to point out, there are 4 non-polarized electrolytic caps on the board. We've got these 3 across the top, which are all the same, and then C52 down here, which is a different value. Doesn't matter which way you put those in. And remember, we took off a handful of components to get in there to clean a little better. Need to get those put back on. So I have to clean the legs here, straighten them out. And I've got pictures in my archives of all these common spots that corrode and where all the parts go. These caps are a little tricky because they have these tubing around the legs, so you've got to kind of tip the board up and hold your mouth just right to get those poked in there. Okay, I pulled this battery out of my stock. This is one of the ones I was sent. They're both basically the same thing, 3.6 volt, 80 milliamp hours. I noticed this one didn't have a positive marking on the shrink wrap that's on here. But if you look at the end, you can kind of see, if it's not too reflecty, the plus on both ends. And the positive end has an extra little snout. So you need to get the holes for the battery nice and clean because it's a tight fit. Just gently wiggle that in there. You notice this has a flat spot under that lead. You want that flat spot on the board. That way your battery's not wiggling all over the place. When I tip these back a little bit and hold the battery in place. And there's a lot of thermal mass here, so what we're going to do is tack each side, push the battery up, make sure it's in place, and we're going to hold that iron on there for maybe 8 to 10 seconds. And I've got my iron set to 640 degrees Fahrenheit, which is 336 degrees Celsius. All right. So we've got our board repopulated with components. There is one thing I noticed. Let me get the paperwork for that. Back on the 20th of May, 1983, Radio Shack released this product bulletin, which states that R91, 94, and 99, they should be 300 ohm, but they accidentally put 5.6K in there. That is this guy, and this guy. These are in the output circuitry right here. And with those resistors in place, you get too little current flowing through there, and it will cause problems, unreliable RS-232 communication with some devices. If you do a loop back, from transmit to receive, it will just barely work. The voltage levels are that close. So after finding that out a few years ago, I always check each board that comes in. Fortunately, those just get replaced with 330 ohms, which for some reason I have hundreds of. So I'm going to swap those out while I'm working on this board, and then we'll be just about ready to test it with the test harness. I just soldered those resistors in, and now I'm going to go back and clean up the board with the Q-tip from all the soldering that we just did. Remember, your mom doesn't work here. Clean up after yourself. We spent so much time cleaning that old nasty flux off the board that I'm not going to leave any more for the next guy. And this doesn't take very long. You have to go after it a few times, but you'll get it. A little bit more cleaning. These DC jacks tend to get corroded. I've got some DeOxit in this syringe. Makes it a little easier to apply without making a big mess. I'm just going to apply some in there. Got a brass pin here with the wick extended out. Stick that down in there and work it all the way around the best you can. I've been able to revive some pretty corroded barrel jacks this way. Okay, now also want to take the DeOxit, squirt some in the reset switch. Oops, basically all the switches. Battery switch. Doing it with the syringe is much less messy. Okay, probably won't use the modem switches, but we're going to juice them up anyhow. Just for good measure. There we go. Yeah, now I'm out of the DeOxit in here, so I'll go around and I'll get the rest of the connectors to get those all cleaned. Sometimes cleaning the board with that, flux and alcohol will flush that into some of these other connectors, so I just want to make sure that's all cleaned up. So I've got the test harness hooked up here. It consists of a ROM board, which has a memory mapped LCD. This replaces the system ROM. We've got a flying lead over here that goes over to pick up the right signal, since we wouldn't normally have a right signal in a ROM. There is a LCD loopback dongle to check those signals, and the 3 supply voltages, keyboard loopback. And there's a connection board back here which connects to the system bus and all the other I/O to test those. It's connected to the cassette and the BCR port. So I'll get you zoomed in here a bit. Turn it on so you can see the power board. I have a loose solder joint on this board, so sometimes it'll fail on the loopback test, but everything else will work. So if we get that, don't worry about it. I like running it with these 2 loopbacks in place to make sure all the tests pass, except for maybe that one because of this board. Then I'll plug in the LCD and keyboard so we can test those. So let us turn that on. Okay, there we go. Now we've got lights here, which you might be able to see. I'll zoom in on the LCD. And the .mgg, it means it's testing all 4 of the RAMs and they're okay. Testing the parallel I/O, it passed. That's the LCD dongle, that's okay. Okay, so we did get a BCR failure. It did go through everything else okay, so now I'm going to remove these loopbacks. We'll plug in our keyboard and LCD here. Okay, now that we've got everything plugged in, I'm going to reseat the BCR connector a few times to make sure we're not just having a problem there because of a bad connection. Check all the connections here on my connector board, which is here. That all seems hunky-dunky. Alright, so the next time I switch this on, we're going to see a slightly different message for the RAM test. There'll be a B, which just means the battery backup worked. Then we'll wait for the test for the LCD and keyboard to come up. Huh, we did not get the B there, so we'll have to check that. We do get our LCD test message. It's kind of hard to see there from the reflection. Now I'm kind of looking at the LCD under here, waiting for it to get to the keyboard test. Now we're getting a parallel port failure. That's odd. BCR fail again. I think we got some connection problems. Keyboard key. Okay, so you can see there as I press the keys, it tells me on the LCD which key it is. Okay, and we just let it go on through the rest of the test. So this time we had the BCR fail and the parallel port fail. So we'll have to check those. So we had the problem with the memory not being retained between power cycles. I traced that down to the battery I put in there. Not only did I put it in upside down like that, which the few minutes it was in there, it shouldn't have done anything. But I had measured the voltage on it beforehand and it was stone dead. Even when I flipped the battery around and let it charge for a couple hours, it was still stone dead. You can see now we got the B in there as it's testing the memory, which just means that it retained the memory from the last test cycle. I tested the other batteries that came in this bag, and they're all stone dead. I suspect that might be for them rattling around and touching each other and just completely draining. Now, the first test that we did with the test harness, it passed on the parallel port and it failed on the BCR. And I ran some more tests last evening, and sometimes I did a special version of the test firmware that once it got to the past the BCR test, it would go back to the LPT test, the parallel port test. And if I left the BCR unplugged, it would run from 1 to 10 times, run the parallel port test fine, fail the BCR test. And I looked in the manual where it describes the test, and it uses the parallel port strobe line to send data to the BCR port. So if that is not working on the parallel port, you're not going to get a good test on the BCR port. So then I got to looking at the schematics here, and we can see that M14 sends the signal down to transistor T8, which goes out to the strobe. Looking at the code, that's a really fast signal. It's just a spike, a pulse. The buffer chip for the parallel port is here. M14 is here. And right now, the parallel port test is running and it's passing. It'll get to the BCR test. There's a little pause here so you can read the display. Second part of the parallel port test. And of course, if this fails because we have the wire disconnected. If the wire's connected, the parallel port test fails sooner. Now this is running, it's running okay again. If I test pin 7, I should see spikes or pulses. Like right now it's held high. Sometimes it's low. I don't see any spikes or pulses. So I'll try to take some pictures of the scope screen and stick up here. So right now the parallel port test has failed. So I'm thinking M14 might be bad. Coincidentally, my friend had this just fail on his T102. It controls the real-time clock, keyboard, parallel port, and one other thing. And you get some really funky problems when it fails. So since we don't have what looks like the right data out of pin 7, I'm going to go ahead and pull this and test it. And I've got another one pulled to swap in there, and we'll see what that does. I pulled M14 here, tested it on the TL866 in chip test mode, and it tested fine. I even swapped in another one, same symptoms. So that just kind of left T8 here looking like it was holding the bag. And I pulled it out, put it on the component tester, and it tested fine. It's just a little NPN transistor, no big deal. Put it back in, cleaned up my flux mess, and now it works fine. So the only thing I can guess is that there was a little residual flux trapped into the transistor. It was causing some leakage and causing all sorts of problems. I've seen it with up here in the reset circuit and in the power supply circuit. We're running the looping through the parallel port and BCR test, and I'm going to measure that output signal from M14, and I'll pop it up on the screen here so you can see the spikes. We're only catching them occasionally. It's a really short spike, 25 microsecond per division. It's less than half that, so let's say maybe 10 microseconds is how big that spike is. And then you can see when we get to the BCR test, it's banging spikes out there so fast that we just see a constant high. So if we hooked a logic analyzer up with a suitable scan rate, we could see all those spikes. But I've let this thing run in this looping test mode with the LPT, the parallel port, and the VCR test for, you know, a total of about an hour, and it's not missed a beat. So it just goes to prove that even after you spend a lot of time cleaning the board, that nasty old flux can sure bite you in the butt. I'll pop the case back on. It does work, but you'll notice we've got this snazzy blue tape around here, and it's hard to tell with all the reflections from my lights on the ceiling. But this is a bit scratched up. You can kind of see right in here there's a really bad spot. So I've got the Novus number 2 and number 3 plastic polish, and we're going to go ahead and polish this screen off, and the tape of course is to keep the polish from getting everywhere. Okay, we're going to start out with a number 3, which is a little coarser. Clean rag here. This is some scrap t-shirt material. Probably hear the 3D printer starting up behind me. All right, we're going to give that a chance to glaze over, which you can kind of see there. Buff it off. And we'll give it another shot with the number 3. I don't know if we can get all this of the scratches off here, but we'll try to do what we can. Try some of the fine now. Okay, that's going to be hard to tell on camera. It's not perfect. You know, it's not a brand new piece of plastic there, but it's a whole lot better. A lot less scuffing and fine scratches are visible. And we can just peel off our painter's tape. And there's always a little the polishing compound that gets into that crack around there. So just clean that up the best you can. Alrighty, I've typed in the small program burn.ba. I was running from batteries when I did that to test it running on batteries. I like typing it in because it gives me a feel for the keyboard. Everything worked out just fine. This program is not real complicated. It reads from every location in memory from 0 to 65, 535, and if it's a printable character, it prints it to the screen. Just like that. And when it gets done, it will beep and start over. And it prints the time on there so I can tell how long it ran each time it beeps. So I'll move this off of the bench and we'll let it run and see if it passes. Had an interesting failure thanks to running the burn-in program for 24 hours on unit number 1. It started out after about 4 or 5 hours with one missing half vertical stripe as seen in the picture here. And by the end of 24 hours, there was probably 10 or a dozen missing. So I had to swap the LCD out, put a good LCD in, and everything was fine. We'll have a look at the second one, and I'm only going to show you anything on this that's different than the first. We'll go over the general condition first. Looks good, slightly dirty, slightly scuffed LCD cover. Connectors and everything look okay. This one looks like it had a lot of use on the modem. Let's pop the patches off here. Oh, this has one of those funky low profile ZIF sockets in it. That's a good catch. Looks a little dirty inside, and oh gosh, sometimes battery covers are hard to get off there. There's a hair in there, and this battery compartment looks clean. That is refreshing. Okay, so if I don't find anything extraordinary on the inside, then we'll just assume this refurb went pretty much just like the other one. Notice I put a label on each one so I can keep them straight. Inside of unit number 2, I saw a lot of black fuzz everywhere. It confused me for a little bit, and then I thought maybe this was a unit that was kept in one of the plastic carry cases that had the foam inserts that deteriorated over time. So had to clean all that out. Battery corrosion on number 2 was just a little worse than number 1, but thankfully cleaning the flux off wasn't as bad, so it wound up taking about the same amount of time. One surprise on number 2 was a lifted trace when they had soldered in that 40-pin ZIF socket. Somebody used some conductive epoxy to repair it. I scraped that off there, put a jumper wire on, and some sealer over that to fix it a little better. In the power supply section of the board, I did have to put in one jumper where a trace had partly corroded away from the through hole. On the exterior, number 3 was very similar to number 2. When I popped it open, I found this little spider's nest under the option RAM number 3 socket. That's a first. Number 3 also had some corrosion just under the memory battery, which is a little more unusual for a Model 100. A little more common for a Model 102. Number 3 had a jumper on the front side of the board in the power supply area, just like number 2. I also had this one in the power supply area on the back due to corrosion in the same area. When typing in the burn-in program on number 3, I noticed that the 5 key would stick down. It took me a second to realize it was a problem with broken plastic. When you push the key all the way down, it let it tip, and it would stick in place. So I swapped the key out with one from the 3 extra units that this gentleman sent along. Well, we got half of our 6-pack all fixed up here. All of these have been through a refurbishment, new caps, new memory battery, corrosion cleaned up, everything tested to the best of my ability to test everything on these guys. I'm pretty confident, though, that these will work for many years to come, and they still look nice as well. Now, we still have 3 to go. These have more serious cosmetic issues. There are 2 of them which have screens that look like this. The plastic is almost melted or scuffed up, or has like, I don't know, something rough like concrete sitting on the top. So I don't know what we'll do about that. This is the one I borrowed the number 5 key out of because the plastic part's broken. I do have one spare keyboard that I can borrow a key out of maybe and put in this. So it'll be interesting to see what we can do to kind of cosmetically fix up these remaining 100s. For now, I'll get these sent back to the owner so he can start using them again and enjoying them. If you have any questions or comments, I would love to hear from you. Just leave in that comment section down there below. Thanks to everyone who helps support the Hey Birt channel. It's greatly appreciated. You help keep this whole thing going. And until next time. Bye.